According to scientists, your brain has a capacity to store entire internet's data, yet you forget most of the things. Every day, your brain processes countless information, from everything you see, hear, and experience. But not all of it makes into your long-term memory. Let's take a closer look into how your brain decides what to store and what to forget. To understand how memory is stored in the brain, we need to explore three key components: the cerebral cortex, hippocampus, and neurons. Now imagine your brain as a computer. Just as input devices like keyboard or microphone collect and convert data into binary format, your sensory organs, eyes, ears, skin, nose, and tongue, send signals to sensory cortices in the cerebral cortex. Each sense has its own dedicated region in this input processing hub. Once sensory data is processed, it is sent to hippocampus. This region is a small seahorse-shaped organ, located deep inside, right at the center of your brain. Just like computer has processor, human brain has hippocampus. It helps in organizing and preparing memories for long-term storage. However, unlike a computer with a specific hard drive, your brain doesn't have a central storage unit. Instead, this is where neurons come into play, creating intricate networks to store memories across different regions of the brain. Neurons are the building blocks of the nervous system, forming intricate networks that powers the brain, spinal cord, and nerves. There are about 100 billion neurons in the human body, of which 80% reside in the brain. These neurons are responsible for everything you think, feel, and remember in your daily life. Each neuron has a soma, the central hub containing the nucleus, where vital cell functions occur, an axon, a long, slender fiber that transmits electrical signals to other neurons, and dendrites, branch-like structures that receive incoming signals from neighboring neurons. These neurons connect through specialized junctions called synapses, where chemical and electrical signals flow to create communication pathways. When the hippocampus processes sensory information, neurons communicate by transmitting electrical impulses across synapses, creating distinct patterns of activity. You can think of it as a secret handshake between neurons. With repetition, these synaptic connections become stronger. This phenomenon is known as synaptic plasticity. This makes it easier for the same neurons to activate together, reinforcing the memory. This principle is often summarized as neurons that fire together, wire together. Memories stick around when the connections between neurons are strong, and remembering those memories again and again makes these connections even stronger. On the other hand, weaker connections lead to fading memory, much like a bridge collapsing when neurons stop exchanging their signals. As the bridge connecting neurons crumbles over the time, the memories disappear. Memories are not stored in individual neuron, but spread across intricate networks of brain. Imagine your brain as a giant constellation of stars. Each memory has a distinct pattern. A memory is like a unique sequence of stars glowing together. When you recall a memory, your brain reactivates specific neural circuits, which are connected to that respective memory. Over the time, hippocampus meticulously organizes and transfers these memories to cerebral cortex, creating a vast library where each region specializes in storing different types of sensory inputs. These memories weave into the brain's intricate and layered architecture, forming the essence of who we are. Recalling a memory isn't just replaying a moment, it's a dynamic process. A familiar scent, a song, or even a random image can act as a spark and can reignite the neural network that once captured it. As the neurons fire in the same pattern, the brain not only brings the memory to life, but also strengthens and reshapes it, adding new details along the way. This fascinating phenomenon is called neuroplasticity. It ensures that memories are not static. They evolve as you grow, adapting to your changing environment. But what happens when neurons die? Does the memory vanish with them? While it's true that the loss of neurons can weaken connections and make some memories harder to access, our brain is a marvel of resilience. Even in the face of challenges like Alzheimer's or stroke, the redundancy built into neural networks helps preserve many memories. Remarkably, neurons can live as long as we do. They live more than 80 years. Taking care of these delicate neural network is essential for a healthy brain. Like a diet rich in antioxidants and omega-3 fatty acids, regular physical exercise, quality sleep, and meaningful social interactions thrive the neural health. These simple steps can keep your brain's city of lights bright, preserving the memories that shape your identity. So the next time you recall a cherished moment or relive an unforgettable experience, take a moment to marvel at the intricate dance of neurons making it possible. Your brain is not just a storage device, it's a masterpiece of nature, preserving the threads of your identity while adapting to the future.